Most astronomers and theoretical physicists endorse the idea that our universe started with the Big Bang. However, problems with dark matter, dark energy, and cosmic expansion have some astronomers rethinking what we know about the early universe. Our universe appears to be expanding and cooling, having originated some 13.8 billion years ago in a hot Big Bang. However, it's plausible that what we see from inside our universe is simply the result of being inside a black hole. This is one of the most fascinating and yet least discussed possibilities in modern physics. Several scientists are now considering this outlandish idea while trying to connect the singularity in the black hole with the singularity in the Big Bang. It's completely baffling but grounded in sound mathematics. While it may sound strange, it could actually be the best explanation of how the universe began and what we observe today. Near the time of the Big Bang, entropy was very, very low and has been increasing for the past 13.8 billion years. The question is, why did the universe begin in such an ordered state? Many physicists say this is the biggest question in physics because the universe tends toward disorder. That's the way it works. Everything gets more and more disordered. But near the time of the Big Bang, entropy was very highly ordered. This is why the universe could have gone in many directions. The Big Bang is considered a quantum fluctuation, and it came into existence in this highly ordered state. It's been getting more disordered ever since, but the measure of disorder is a measure of the probability that you will spontaneously create. So, if you're very ordered, it's very unlikely you'll create it. If you're less ordered, it gets more and more likely you'll do it. That's why things get more disordered. The universe today is less ordered than it was then, so it's far more likely that it would fluctuate into existence now. It's more likely that the whole universe with us in it, having this conversation and everything we can see, would fluctuate into existence than it is that the Big Bang fluctuated into existence. Black holes are perhaps the most extraordinary and intellectually challenging naturally occurring objects found anywhere in the universe. Some of the black holes observed today are many billions of times more massive than our Sun. Delving into the mysteries of our universe, Professor Brian Cox explains how they are formed and why they are essential components of every galaxy, including our own, and what secrets they still hold waiting to be discovered. So, I talk about cosmology, what we call the large-scale structure of the universe, the galaxies, and how they formed, how the universe has evolved since the Big Bang, but also black holes. Black holes are really evocative things. I think everyone's heard of these strange things, these totally collapsed stars from which nothing apparently can escape. But in the past few decades, really beginning with work that Stephen Hawking began back in the 1970s, and many others, we've begun to suspect there's a lot more to them. They've started forcing us to reassess our understanding of what space and time are. Black holes are kind of a metaphor in a way. By studying them, we're beginning to get a deep picture of what our reality actually is. That's a remarkable idea, but it's just a region of space from which even light can't escape. Stephen Hawking calculated that black holes glow in the sky like coals, and they radiate. So, over time, they lose energy and mass and ultimately disappear over huge timescales. This was key in trying to understand what happens to this stuff that fell in when you thought these things existed forever. Then, suddenly, you have to face this question: what happened to everything then? If I threw a book into a black hole, is it somehow possible, in the far future, if you collect all the so-called Hawking radiation that comes off, is it possible to reconstruct the information in the book? That's been a question that's driven a tremendous amount of research for 50 years, and it was pretty much solved in 2019. Actually, the statement is everything comes out again. All the information comes out. So, in principle, in the far future, you could reconstruct the information of everything that fell in. If you fall into a black hole, your body could be subjected to a process called spaghettification. So, if we are inside a black hole, how is it that we are not getting twisted, torn apart, or spaghettified. Dr. James Beecham, a particle physicist at CERN, searches for answers to the biggest open questions of physics and explores this phenomenon thoroughly. To make a black hole out of the Earth, you need to pack the entire Earth into a volume about the size of a blueberry. Most black holes we know of are much larger than this, with masses that are billions, tens of billions of times that of the Sun, and with volumes that would encompass our entire solar system. What about the observable universe? We know that the universe is expanding, but expanding into what? Nothing. Space itself is expanding because of the particular way that the universe expanded right at its birth. We also know that there are parts of the universe that are currently unobservable to us. They are outside of the so-called observable universe. So, the observable universe is defined as this sphere that's around you, composed of all the stuff that has had a chance to send a light signal that you could receive. But beyond that, we have no idea how big the entire universe is. It could be infinite. In fact, it could be something smaller. We don't know. If you wanted to make a black hole out of the entire observable universe, you would need to pack it into a sphere that's a little larger than the current observable universe. Do we live inside an enormous black hole? It turns out that as long as the black hole is large enough, you would be okay. It would still be a one-way trip. Once you cross this event horizon, there's no way for you to go back out. But it's entirely possible that our observable universe right now exists on the interior of an enormous black hole. Black holes are more than astrophysical oddities. They could help us answer one of the biggest open questions, long-standing questions, in physics. And this is the question as to whether gravity and quantum mechanics have anything to do with each other. Scientists continue their quest to try and combine these two theories, hoping for a more fundamental theory of the universe. Thanks for watching. Did you like this video? Then show your support by subscribing, ringing the bell, and enabling notifications to never miss videos like this.